Good evening, dear students. I welcome you all on behalf of Indian Medical College. So, in today's session, we have our enthusiastic speaker, Dr. Anjali Shete ma'am, who is Associate Professor from the Department of Physiology from GMC Medical College, Aurangabad with us. And she is having a plenty of teaching experience behind her. She'll be taking a class on respiratory physiology revision today. Good evening and welcome you, ma'am. It is an immense pleasure to have you here with us.
Thank you, Dr. Kavya.
Thank you so much, ma'am. Ma'am, you can start the presentation. So, student, you have any doubts, you can just post it in the comment section below. Ma'am, please.
Okay. Thank you. Now, hello students. We have seen some part before also. So I think now online at least we know each other well. So we'll start with one more system, revision system, that is the respiratory system. So today I'm going to discuss some important questions of the respiratory system. So the first question, which is very commonly asked in the examination, is describe the transport of oxygen in the blood and add a note on Bohr's effect. The same question can be asked in the examination as explain the oxygen hemoglobin curve with the help of a diagram and discuss the factors affecting it. So very commonly these questions are asked in the examination. Now what exactly you have to write for this? Now whenever you are writing a long essay questions, you have to start with the introductory part first. So what you are going to write for this particular question is how the oxygen is transported. What are the different modes of oxygen transported? Oxygen is transported from lungs to the tissues in two methods. Firstly, it is physically dissolved in the plasma, and secondly, it is in combination with hemoglobin, which is present in the red cell. The physical dissolved form is only 2%, whereas the combination of hemoglobin, 98% of the oxygen is carried in this matter. Now, this dissolved form of oxygen at around partial pressure of 95 millimeters of mercury is only 0.3 ml. That means the 0.3 ml of oxygen is transported in dissolved form in 100 milliliters of blood. If you consider your cardiac output as 5 liters per minute at rest, the oxygen transported in dissolved form will be only 15 ml per minute. So this is not going to meet the oxygen requirement, which is grossly inadequate because our oxygen need is around 250 milliliters per minute at rest. So what the body does is, but the use of this particular dissolved form is we can use this as an oxygen therapy, hyperbaric oxygen therapy. Nowadays, it is very commonly everywhere you are knowing that the COVID infection is needed the oxygen therapy. And in this particular form of oxygen therapy, the dissolved oxygen form is more used. So there are some conditions where the transport of oxygen in dissolved form is very much useful. But at rest, in normal condition, this is not sufficient. So majority of the part of oxygen, that is more than 98% of oxygen is transported in combination with hemoglobin. So why it is possible? Because the hemoglobin, it has a binding affinity for oxygen. Whenever the oxygen is combined with hemoglobin, the hemoglobin is known as oxyhemoglobin, and if it is not binding with oxygen, then it is termed as reduced hemoglobin. The oxyhemoglobin, why this hemoglobin? Just a revision of your hematology lectures. The hemoglobin molecule is a protein which is made up of four subunits which are bound together. Each subunit consists of a molecular group known as heme and a polypeptide attached to the heme. The four polypeptides of a hemoglobin molecule are combinedly known as globin. This each heme group contains one atom of iron to which oxygen is binding. So this is the structure of hemoglobin. Now these four subunits, they can have an attachment for the oxygen and they form the four heme sites will be attaching to the oxygen and they can carry four molecules of hemoglobin. So this is how the reaction, which is an reversible reaction, will be happening to transport the oxygen along with hemoglobin. So the first reaction, whenever occurs, the first molecule of oxygen, if it is combined with hemoglobin, the next reaction will be much faster, the next will be much faster, thus the affinity goes on increasing. Now there are terms which are very commonly asked. Oxygen carrying capacity of the hemoglobin. So you know there are four sites for the binding of oxygen. So thus each gram of hemoglobin binds with 1.34 ml of oxygen. The maximum amount of oxygen that can be carried by hemoglobin is known as oxygen carrying capacity. These are the common terms which are asked in the examination, even in the practical classes or in the viva classes. So in a healthy individual, the oxygen carrying capacity of arterial blood is around 20 ml of oxygen per 100 ml of blood if we consider the hemoglobin to be 15 gram per cent. So this is the oxygen carrying capacity. Then what is oxygen content? It is the amount of oxygen which is actually bound to hemoglobin. Whereas the oxygen capacity is the amount of oxygen that can potentially bind with hemoglobin. So these are the two different terms which you should know. Then comes the percentage saturation. The percentage saturation of hemoglobin with oxygen is the ratio of the quantity of oxygen actually bound to the quantity that can be potentially bound multiplied by 100. So it is the ratio of oxygen content and oxygen capacity. Now this particular transport which is occurring in combination with hemoglobin is stated with the help of a oxygen hemoglobin dissociation curve. Actually it is an equilibrium curve. So it is dissociation also and association also. But very commonly it is termed as oxygen hemoglobin dissociation curve. And this explains the relationship between the partial pressure of oxygen in blood with saturation of hemoglobin. So this particular curve gives you an idea at what pressure of oxygen, how much saturation of hemoglobin or how much oxygen will be combined with hemoglobin. That idea will be given by this particular curve. This oxygen hemoglobin equilibrium curve is an S-shaped curve over the range of partial pressure of oxygen from 0 to 100 millimeters of mercury. So this is a very common separate question which can be asked as a long answer question. So you should have a habit of drawing this particular oxygen hemoglobin curve. Now this sigmoid shape of the curve, which results from hemoglobin affinity for oxygen at various partial pressure of oxygen. Now as the PO2 rises, the hemoglobin saturation is progressively increasing. This saturation is not linear with increasing partial pressure of oxygen, and that is why the curve becomes a sigmoid shape or it gets an S-shaped curve. So we are going to see this particular thing. Now we can see on the x-axis there are partial pressures of oxygen which are given, and on y-axis the hemoglobin saturation is there. Now this particular saturation, if we consider this as the pressure, see this is the normal ranges of the pressure from 0 to around 100, 105, 110 pressure. So at the lungs level, there the oxygen pressure as it is more, the hemoglobin which is present in the blood will be attached to the hemoglobin and the blood will transport this oxygen towards the tissue. Towards the tissues. So this is how it is transported. Now at this particular shape is the tissue space. So here the partial pressure of oxygen is less, and this partial pressure of oxygen, the hemoglobin binding capacity of oxygen will be reduced. That means the oxygen will be released at this particular pressure. So if we are going from this side to this side, this will be attachment of the oxygen to the hemoglobin at the lungs level, and as you go downwards, it will be showing the release of oxygen at the tissue level. If we are considering in the opposite direction, if we are going from zero partial pressure, then what will be happening? So as the pressure increases, the binding capacity of the hemoglobin with the oxygen goes on increasing. So if you consider from 0 to 60, there is a steep rise. So this is one part of the oxygen hemoglobin curve. And beyond 60, there is a plateau phase. So this particular phase is known as a plateau phase. So this curve will be divided into two parts. One, a steep part, and the second is the plateau phase. So this is how we are going to see this. Now you have to explain what is steep phase and what is plateau phase. The steep phase is the slope between the partial pressures of oxygen between 10 to 60 millimeters of mercury. And during this phase of the curve, the combination of oxygen with hemoglobin increases very rapidly. And as the PO2 increases from 10 to 60, the saturation of hemoglobin is around 90%. So we can see that, see, this is 10 and this is 60. So if you see the oxygen saturation, it is around 90%. So very rapidly the oxygen is combined with hemoglobin. So this is the steep phase. What is the significance of the steep phase? In the steep phase, the oxygen saturation is very high and this facilitates the oxygen loading. The attachment of oxygen with hemoglobin is facilitated. Also, change in the steep portion, as I have explained, in the reverse direction, that is from 60 to 10 millimeters, it causes the unloading of oxygen in the tissues. So whenever there is a small decrease in the PO2 in the tissues, unloading of the large amount of oxygen to the tissues will occur. And this is the condition where the tissues are in need of oxygen. So the steep phase allows large quantities of oxygen to be released from hemoglobin in the tissue capillaries, whereas a lower capillary PO2 prevails. And this is especially achieved by shifting the curve to the right. So whenever there are changes at the tissue metabolism, this is the part which is shifting. We have seen that there is a shift of the curve to the right, the shift of the curve to the left, but this is the steep part which is moving, not the plateau part. Now coming to the plateau phase, the curve begins to plateau at around partial pressures of 60 and beyond that. So it becomes flattened. The increase in PO2 above 60 produces only a small increase in oxygen binding. Why? Because already 90% of the hemoglobin is saturated. So only 10% has to be saturated. Now this increase in PO2 from 60 to 100 millimeters in the plateau region of the curve illustrates the oxygen saturation and the content which are remaining apparently constant even if there is a wide alterations in the partial pressure of oxygen. What is the significance of this? This particular plateau phase gives us a safety factor. So whenever you are having any pulmonary disease or if you are moving at a high altitude, there is a decrease in the partial pressure of oxygen, but this provides a safety factor. The significant decrease in the lung function can allow to have the normal saturation of hemoglobin, even at high altitude or even suffering from a moderate type of hypoxia. So the oxygen saturation and the content remain fairly constant in spite of wide fluctuations in the alveolar partial pressure of oxygen. And this is the importance of plateau phase. Now, this is what is actually your curve, the oxygen hemoglobin affinity curve. So this particular oxygen hemoglobin affinity will be affected by different factors. The most important factor which is affecting is hydrogen ion concentration, the carbon dioxide partial pressure, temperature, the concentration of 2,3 ppg, and sometimes special conditions like carbon monoxide poisoning or the variants of hemoglobin. So these are the factors which are affecting the combinations of oxyhemoglobin. Now how they are going to change it. So this is the particular curve which is showing the middle one is the normal curve and one curve is a right shift and the second part is left shift. Now you can see whenever there is a shift of the shift of the curve normally is occurring only in the steep part. not occurring in the lactic part. So that first thing you have to remember. Now, whenever there is a right shift, what does it mean? The affinity of the hemoglobin towards oxygen will be decreased. So these are the conditions whenever there is a decreased affinity of hemoglobin towards oxygen. So what are these conditions? Whenever the temperature is decreased, whenever the partial pressure of carbon dioxide is increased, whenever the pH is decreased, whenever there is increase in the 2,3-DPG levels. So all these conditions will decrease the affinity, decrease the binding of oxygen with hemoglobin. That means, see, if you concentrate on these factors, these are the metabolic end products. So there they will be at the tissue level. So at the tissue level, the tissues are requiring the oxygen. So that means the blood should release the oxygen. So these are the conditions when this will happen at the end of the metabolism. The affinity of the hemoglobin towards oxygen will be decreased and the shift of curve will occur. That means it will release the oxygen. Just the opposite thing will happen here in cases of the reverse shift. Okay, so what we have, there is increased affinity. So the hemoglobin is binding more affinity towards the oxygen. What are the conditions whenever there is decrease in the temperature, whenever there is carbon dioxide pressure decreased, whenever there is decrease in the 2,3-DPG, and whenever there is increase in the pH level. So these are the metabolic factors. So as the tissue metabolism will be changing, the hemoglobin oxyhemoglobin dissociation curve will try to adjust the release of oxygen by shifting the curve in both the directions. So these are the metabolism which are occurring inside the body. As per our metabolic requirement, the curve will be shifting. That means it will cause the release of oxygen as per the requirement of the body. These are the abnormal conditions. Say, for example, there is a carbon monoxide poisoning. The hemoglobin, if it is attached to the carbon monoxide poisoning, this is the type of curve which is occurring there. But this, if you have time, you don't have to draw this particular figure. You can mention as one factor in your exam answer that whenever the carbon monoxide is there, it will be attaching with the hemoglobin and it will not have any part which is free for oxygen attachment, so there will be hypoxia. There are various factors which are affecting the 2,3-DPG. We have seen that 2,3-DPG is going to affect the oxygen hemoglobin affinity, and one of the factors, 2,3-DPG, which is present in the red cell as a metabolic factor, is affected in turn by different factors. So if they are changed, the 2,3-DPG will be changed, and as this is changed, the oxygen hemoglobin affinity will be changed. Now, what are these factors? The first important factor is pH. So the pH is the important factor that decreases the 2,3-DPG concentration. Then if you have different types of hemoglobin, say for example fetal hemoglobin, it has a less avidity for 2,3-DPG than beta chains which are present in the adult hemoglobin. So fetal hemoglobin has higher oxygen affinity, and this provides an advantage to fetus to extract oxygen from maternal blood in the placenta. So fetal hemoglobin shifts the oxygen hemoglobin dissociation curve to the left side because it is having more affinity for oxygen. Then comes the third point, hormones. We have the secretions normally of these hormones, growth hormone, thyroxine, testosterone, and all these hormone secretion, they stimulate the synthesis of 2,3-DPG. So if there is increase in the 2,3-DPG, there will be the shift of the curve towards the right side. That means there will be release of oxygen towards the tissues. At high altitude, we have seen that at high altitude, the concentration of 2,3-DPG increases, and at hypoxia also, the production of this 2,3-DPG increases. So in both these conditions, the tissues are in requirement of oxygen, so the affinity will be decreased and oxygen will be released. There's one part which is very important. This again is very commonly asked question in the examination as a part of practical exam question or an viva question. Procedure for storage of blood. We store the blood, but what happens whenever we are storing the blood, the 2,3-DPG concentration, it decreases. And due to that, the stored blood decreases the oxygen transport. And so it is very difficult to store this blood. If it is transfused into hypoxic patients, then we have to be very careful that if we are transfusing this stored blood into the hypoxic patients. So we have to keep in mind that if the blood is stored, there is a decrease in the 2,3-DPG concentrations. Of course, if we are changing the storage solution, this can cause some change in the storage properties. So in summary, if we have to write the factors that shift the oxygen hemoglobin to dissociation curve to the right, what are these factors? Increased temperature, decreased pH, increased PCO2, increased 2,3-DPG, hypoxia. And that means all these factors which are facilitating the release of oxygen. So shift of the curve to the right releases the oxygen. Now, what are the factors which are shifting the curve to the left? Decreased temperature, increased pH, decreased PCO2, decreased 2,3-DPG, fetal type of hemoglobin, presence of carbon monoxide. And this causes the oxygen uptake and prevents the oxygen release. So these are, to summarize, the factors that affects the curve. So if this is a long question, the answer you have to compile as modes of oxygen transport, structure of hemoglobin, in short you have to write, then you have to write the oxygen carrying capacity of hemoglobin and oxygen hemoglobin dissociation curve you have to draw. The factors which are affecting the oxygen hemoglobin dissociation curve. This is how you have to complete your long answer questions. Now there is very additional thing which is asked as a part of this, that is the Bohr's effect. So the factors which are causing the shift of the curve towards right is your Bohr's effect. So you can at that particular point add this answer to that. Coming to the next part, that is enumerate the respiratory center. This is the next question. Discuss the nervous regulation of respiration. Add a note on Dice curves. Very commonly asked question as a long answer 10 marks question. Again, you start with the introduction. So the normal rate of respiration in adults is around 12 to 18 per minute. The tidal volume is around 500 ml, and this is adjusted to the requirements of the body. So these are the basic things. But as our body is changing, going to change the metabolism, this will shuffle, and according to that, the respiration is regulated. What are these control mechanisms? So mostly the control mechanism is voluntary control, involuntary control, and there is a spontaneous respiration. It is said that respiratory system is the only one system in our body which has dual control. It has an involuntary control also, and it has an voluntary control also. So these are the control mechanisms. You can control your respiration voluntarily. You can control automatic, or there is a spontaneous respiration. So one by one we are going to see this. What is the voluntary control? The voluntary control, of course, is through the cerebral cortex. Why we need it? These are some figures. If you concentrate on these pictures, see, nowadays in this lockdown, we have so many times seen Mr. Modi giving a speech. Okay, this is Shankar Mahadevan, known for his breathless singing. Singers making records, and sometimes we laugh for minutes together. How it is possible? Now, during each of these acts, you have to control the respiration voluntarily. So, if you have, suppose I am talking to you, this particular speech, I have to regulate voluntarily my respiration. Sometimes it loses, then there are breaks you can see. So, this is the functional significance of voluntary control. Why we require it? Because it facilitates the acts like talking, singing, swimming, laughing, for breath holding, and for hyperventilation. So these are few things where you require the voluntary control. And this is via cerebral cortex. Coming to the involuntary control, which is very much important. Most of the time in the examination, you have to write the answer in detail regarding this involuntary control. What is this? This is important for genesis of normal respiratory spontaneous rhythm. It also controls the rate and depth of respiration. Now for this, there are centers. What are the centers? We have medullary respiratory center, you have pontine respiratory centers, and you have reticular activation system. So with the help of these three factors, there is involuntary automatic control of respiration. Coming to the medullary respiratory center. So this is medulla, and in this medulla, you can see this is pons and this is medulla. We can see there are two groups of neurons. One is dorsal group of neurons, and the second is ventral group of neurons. So the medullary respiratory centers, which are important for controlling the respiration, are two parts: dorsal respiratory group of neurons and ventral respiratory group of neurons. How they are going to control? First, the dorsal respiratory group of neurons. These neurons are very near to the nucleus of cactus solitarius. And this particular group of neurons, they contain mostly the inspiration neurons. And why these are termed as inspiration? Because they are discharged during only the phase of inspiration. See, for example, this is a figure. So this is the inspiratory neuron and this is expiratory neuron. The inspiratory neuron, if it is stimulated, then you start your inspiration and this will go like this. And this is known as inhalation, inspiration. And at one point, the stimulus will be stopped and we will be starting the exhalation. If you remember your lectures of mechanics, the inspiration is an active process whereas expiration is an passive process. So the dorsal respiratory group of neurons, what it produces a ramp signal, a rhythmical discharge that causes a steady rise in inspiration which continues for 2 seconds. And after 2 seconds, the inspiratory switch off neurons will be activated and they will abruptly end the inspiration for next 3 seconds. And during this next 3 seconds, the expiration is occurring. This is how the control of frequency of respiration, the number of respirations is controlled by dorsal respiratory group of neurons. So it initiates the ramp signal and then it controls the frequency of respiration. So that is the importance of this dorsal group of neurons. Now, what is the importance of ventral respiratory group of neurons? This ventral respiratory group of neurons, it has three parts. There is a caudal part which is near to the retroambiguous, it contains the expiratory neurons. The intermediate part which contains the inspiratory neurons, and rostral part is the Bort-Singer complex which again contains the expiratory neurons. So this is ventral respiratory group of neurons. What is the function of this? As we can see that there are both inspiratory neurons and expiratory neurons. So the function is in both inspiration as well as expiration. So they are normally totally inactive in quiet breathing. They become active only during the forceful respiration. Say for example, you require during exercise more amount of respiration. At that particular point only they will be active. Otherwise, normally, the normal resting respiration is completely maintained by dorsal respiratory group of neurons, and they have the reciprocal innervations. So these are medullary centers. Coming to the pontine respiratory centers. In the pons, again, one center which is present is in the nucleus parabrachialis in the upper part of the pons. That is the pneumotaxic center. Now, what it does, it continuously inhibits the inhibitory center. So, this particular pneumotaxic center continuously inhibits the dorsal respiratory group of neurons. That what is the action of dorsal respiratory group of neurons? It is initiating the inspiration by ramp signals. So if it is inhibited, that means the pneumotaxic center is inhibiting the inspiratory neurons. And due to this particular inhibition, the increase in the rate of breathing is there. That means the ramp signal, say for example, it will be continuously doing. Okay, so the continuous rate and depth is controlled by the pneumotaxic center. So there is inhibition, and due to this inhibition, whenever you require a fast rate, this inhibition will be adjusted accordingly. If you require a slow rate, again it will be adjusted according to your body metabolism. So this is the function of pontine respiratory center. In some books, there is a mention of apneustic center also, but the role of this particular center is not clear. Mainly, it is said that it prevents the switch off of RAP. So it increases the depth and duration. So a prolonged respiration will be possible. Normally, this is kept inhibited by vagus and the hemotaxic center. But the itself apneustic center is many of the books does not mention the apneustic center. So this was the second part of the control, that was the involuntary control. The third part, which is control of breathing, is spontaneous breathing. So what is the spontaneous breathing? There are some pacemaker cells which are situated in the pre-Botzinger complex on either side of medulla, and they are discharging continuously to have and spontaneous breathing. And these are the cells which are responsible for spontaneous breathing. So, in short, what we have seen is voluntary control through the cerebral cortex, the spontaneous breathing through the pre-Purkinje complex, and involuntary control through the three centers. The first one, the medullary center, the second one is pontine center, and the third one is reticular activating system. So there is a role of reticular activating system in regulating the respiration. How? Because it increases the respiratory drive. Whenever during sleep, this RAS activity decreases the respiratory drive, and that causes the alveolar ventilation to decrease. So during the resting stage, during the sleep stage, the reticular activating system activity will be decreased, and that will cause the decrease in the respiration. So accordingly, whenever in the daytime it will be activated, you can adjust the regulation or rate and depth of respiration, whereas during sleeping you can adjust accordingly. So this is the function of reticular activating system. There is one abnormality which is concerned with this, is that which is very commonly asked on Dyspers. This is actually the congenital central hypoventilation syndrome, which is very rare, severe form of sleep apnea, in which an individual is completely stopping breathing when falling asleep. So what happens is that even during sleep, we respire, we take the respirations, but in this particular condition, there is a complete stoppage of breathing. So these persons are said to have a curse that they have to remember to take the respiration. So this is Ondine's curse. So this is a very good figure which I have taken from internet. I think Dr. Arif, the name is given. I don't know regarding him, but this gives an idea regarding whole of the respiration. See, this is your pons, this is your medulla. You have the pontine respiratory group, you have the dorsal respiratory group, you have the ventral respiratory group. In the medulla, you have these two centers. In the pons, you have this one center. So these centers, via the nerves, this is the spinal cord. So they will give, these centers will give the nerves, and these nerves are going to supply the muscles of respiration. The major muscle, of course, is diaphragm, and the second major muscle is external intercostal. So these nerves will be supplying to these muscles, and accordingly, this is a connection which is made from the center to the muscle, and the activity of respiration, the control of respiration is done. Now, these are the answers which you have to write if your question is regarding the nervous regulation of respiration. But apart from that, you also can have one short notes differently which are asked on these particular parts, which are I am going to discuss in the coming sessions. That these respiratory centers, they are influenced by various other factors. One of the important factor which is very importantly affected is chemical receptors. So that comes under chemical regulation of respiration. It's a complete different part that will be a different session. So what I'm not going to discuss this particular part in this session. What I am going to discuss is how the higher centers are going to affect the respiratory center activity and what are the different non-chemical receptors which are going to affect the respiratory centers. Now, how these higher centers, as we have seen in the previous slide also, that the voluntary control of the system is done by neocortex. So it bypasses the medullary respiratory centers and directly projects the spinal respiratory neurons. And they are important for talking, singing, screaming, and breath holding. You also have a control of respiration via the limbic control system. And this is via the pontomedullary respiratory neurons. That alters the respiration during pain and emotional stimuli. You must have observed it. Like say for example, if you are doing yoga and pranayama, so you can hold your breath. So this is voluntary control. Watching a movie, a horror movie, you hold your breath. So there is an emotional stimuli and immediate reaction is there. If you are watching a cricket match, the last ball of the cricket match, then you see the reaction. So you hold your breath for that. And this is how, from the higher center, the respiration process is influenced. There are various non-chemical receptors also, and all of this can be your viva questions, can be your brief answer questions, can be your short answer questions. So any of these can be asked in your examination. So what you have is pulmonary stretch receptor, which is very commonly known as hearing blower reflex. Then from J receptors, from evitant receptors, from proprioceptors, chest wall stretch receptors, baroreceptors, and thermoreceptors. So all these non-chemical receptors can affect the respiration. One by one, we are going to discuss this. So, say for example, you know that tidal volume is normally 500 ml. But if your tidal volume is more than 1 to 1.5 liters, what will happen? There will be lung will be inflated. And there are stretch receptors which are present in the bronchi and the bronchioles. They will be stimulated due to this stretch. And this impulse is carried via the villi to the pontomedullary respiratory centers and the inhibition of respiration. So whatever increase in the tidal volume, which was tremendous increase, will be stopped. And this particular reflex is known as hearing blower inflation reflex. So this is a chart I have made to have an good idea what you have. So the stimulus is lung inflation, the stretch receptors will be there. This reflex is known as hearing blower inflation, which are present in the airway and they are carried by vagus. Same way, there will be lung deflation also. That is also sensed by airway stretch receptors and carried by vagus, but it is termed as hearing blower deflation reflex. So these are the pulmonary reflexes. Due to the stretch receptor activities, the respiration is altered. Coming to the J receptors. The J receptors are they were discovered by one Indian physiologist, A.S. Pintal, in 1954. So this particular discovery is in our credit. What is this? These receptors are unmyelinated vagal afferents and they are present very close to the pulmonary capillaries. So what they do is they are sensitive to the increase in the content of interstitial. So what you have is the capillary endothelium one side and alveolar epithelium on one side, and in between that you will be having the interstitial fluid. So whenever there is a change in the interstitial fluid content, these receptors will be stimulated, and if they are stimulated, they will cause apnea, hyperventilation, bradycardia, hypotension, and weakness of skeletal muscles. So these are the receptors, J receptors activity. These are very common examples whenever your respiration will be altered due to irritants. Soft reflex, sneeze reflex. We have just discussed the heading toward deflection reflex. Then you will have the deglutition reflex. You have the reflex tachypnea and bronchoconstriction. So whenever any irritant is entered inside your respiratory tract, that will initiate these reflexes and that will alter the respiration. Then we have the proprioceptors. So these are the touch receptors. They are very much important in the sports person. Why? Because they increase the ventilation during the exercise. Whenever you are having a touch sensation, these proprioceptors will be stimulated. These stimulated proprioceptors will stimulate the inspiratory neurons and they will increase the rate and depth of respiration. Very commonly seen in the sports persons. And again, this particular property we can utilize for normal thing also. Actually, I was trying to include a video here, but it was not possible due to the connectivity problem. So I'm showing only the picture. If you remember, this particular picture is she's Kareena Kapoor, and this particular picture is from Three Idiots. And if you remember the scene of the delivery of the baby, she is instructing online. So in the Three Idiots movie, she was instructing Amir Khan to do the delivery online. After the birth of the baby doesn't cry. At that particular point, the Kareena Kapoor, who is a doctor, what she says is that tap, pat, Maroso. That was the instruction. Why? Because the touch receptors will be stimulating the inspiratory neurons and then they can start the rate and depth of respiration. So this is what very commonly in the pediatric ward, if you are seeing the birth of a baby in your second year, third year classes, very commonly this scene is seen. Then you can have the alteration of respiration from chest wall stretch receptors. So what we have is muscle spindles are there in the intercostal muscles. They coordinate the breathing during the change in posture and during speech. So that is termed as intercostal to intercostal reflex. And this reflex is through the phrenic nerve. So whenever you are changing the posture, say for example during sitting, during standing, during walking, your respiration is going to change, and this is due to chest wall stretch receptors. Then we have baroreceptor activity also. Whenever there is rise in the blood pressure, there is stimulation of baroreceptors, and simultaneously there is inhibition of respiration. So this is how the baroreceptors are also going to affect the respiration. Then the third, via the somatic afferent nerves, this warm receptor stimulation will carry the cerebral cortex and there will be heat loss mechanism. So this is what you have. So in short, in summary, this is the picture which shows the non-chemical activity and the chemical activity, the influence on the respiratory center. So you have list of all these factors which are affecting the respiratory system. I think that is all regarding that today's session. If there are any questions, you can ask me or you can give in the chat box. Thank you very much.
Thank you so much, ma'am. It was a wonderful session. Ma'am, can you please stop sharing the slide? Students, I hope you have all enjoyed this session. So, this is for tomorrow's schedule. So, tomorrow we have the topic on growth as an exam point of view, which has been taken by Dr. Nandita Chatterjee, which is being scheduled on at 5 to 6 p.m. And the second topic is on meningitis, diphtheria, and tuberculosis by Dr. Mohammed Khalid at 6:30 to 7 p.m. Stay tuned. Please share our YouTube page and Facebook page. Subscribe to our YouTube channel to get the SS recorded lectures and also the MCQs and also the sessions furthermore. Thank you so much, viewers, and thank you so much, ma'am. for a beautiful presentation. Thank you for sparing us the beautiful time. Thank you, students.
Thank you very much.
Thank you, ma'am.
Should I leave?